Hi guys, Mr. Fridath again. This is chapter 4, cell structure and function. I'm just going to be going over the first section in this chapter, which is a very short section, but we are starting cells today. So, cells. Cells come in a lot of shapes, sizes. See here where it says 1 millimeter to 1 micrometer. There's a lot of variability with how small a cell can get and how large a cell can get. When we look at bacteria cells, they're much smaller than eukaryotic cells. And there's even a lot of variance and variability with how big eukaryotic cells can be as well. That being said, the cell theory, there are three main parts. First part is all organisms are composed of cells. No duh, right? Like everyone should know that by now. Cells are the structural and functional unit of all living things. So we don't consider anything smaller than a cell to be living. So macromolecules, atoms, molecules, organelles, they're not technically living. The cell is like the most basic unit of life that we have. And cells come from pre-existing cells. So all cells that are living today have come from some kind of pre-existing cell from long ago. So, like for your example, you came from your parents came from their parents, and so on and so forth. All living things come from living things. All living cells come from pre-existing cells. One of the most important aspects of this chapter is going to be surface area to volume ratio. Hopefully you know what surface area and volume are, but surface area is just the outside of any object. The volume is how much of like space that actually takes up. We're going to be looking at the relationship between those two in this aspect. I'm not going to read off the slide. I'm just going to explain to you what surface area to volume ratios do with cells as they get bigger or as they divide. So you are made of trillions of cells. One of the questions that might be asked is, well, why doesn't an organism just get bigger, like one cell, and just get bigger and bigger and bigger? The reason why that doesn't happen is because of surface area to volume ratios. So the big aspect about surface area to volume ratio is as a cell gets bigger, the surface area and to volume ratio is not going to stay the same. As a cell gets bigger, the surface area to volume ratio is going to go down. As a cell divides and keeps the same size, that's going to keep the surface area to volume ratio drastically up. Okay, it's going to increase it. Let me show you what that technically looks like. You can see here we have a cell, we have a representation of a cell. That cell could grow bigger. Two things are going to happen. The volume is going to increase and the surface area is going to increase. But they're not going to increase at the same rate. You can see down here the surface area to volume ratio. As a cell gets bigger, the ratio goes down. What that means is the volume is going to increase more than the surface area will increase proportionally. There will be more volume per surface area. Here you can see we have the same volume. We have many times more surface area. You can kind of think, if we took all the surface areas of each of these boxes and we compare it to the surface area here to this big box, there's going to be way more surface area for the cells here compared to here. Now, what that does, it allows the cell to more efficiently move things in and out of the cell. You can see here, we can imagine that a cell here, just thinking about getting things into and out of the cell, we can think about the innermost part of that cube. It's going to take a lot of energy and a lot of time, which is energy, to get things in and out of the cell. Now, compare it with the cells here. If we drop both of these cells in water, okay, and we have to let that water diffuse into the cell, we're going to get into the innermost parts of these smaller cells much, much quicker than we are compared to this big cell. So what the surface area volume ratio does is as a cell gets bigger, the surface area volume ratio goes down. The efficiency or the energy efficiency of that cell also goes down. Over here, the efficiency drastically increases. When we're looking at evolutionary advantages, you want to be able to move things in and out of your cells as efficient as you can.